Converting is another word for changing, transforming, translating, or switching. So we are going to be changing, transforming, switching, translating, converting fractions into decimals that are equal to them. Some division problems have whole number quotients. For example, 12 divided into 6 equal groups. There's 12 purple dots, and they're being grouped with orange into 6 groups. Each group has 2 dots. This solution is a whole number of 2 dots per group. Some division problems have non-whole number quotients. For example, 3 divided into 2 equal groups. Here are 3 wholes, and if I want to divide them into 2 equal groups, one of the wholes has to be shared evenly between the groups. This means that the solution is not a whole number. It would be 1 whole and then half of a dot per group. That would be the same as 1.5 as a decimal or 1.5 as a mixed number. In the previous examples, the dividend was greater than the divisor. For example, 12 was the dividend, and that's greater than 6, the divisor. 3 was the dividend, and that's greater than 2, the divisor. So what happens if the dividend is less than the divisor? Even though the dividend is less than the divisor in this example, 1 whole is the dividend, 4 is the divisor. 4 is greater than 1, not less. That's okay. We can still take 1 whole and separate it into 4 equal groups. The result is just less than a whole. It would be a fraction amount in each group, and that's okay. Since it's okay to have a dividend that's less than the divisor, that just means that your quotient or your answer will be below 1 whole instead of above 1 whole. In the first 2 examples, we got a solution that was greater than a whole. First we got 2, and then we got 1.5. But in the third example, we got a quotient that was below a whole. We got a fraction, 1/4. So speaking of converting fractions to decimals anyway, a fraction is one of the ways to represent a division problem. For example, 12 over 6 can mean 12/6, but it can also mean 12 divided into 6 equal groups. 12/6 looks like 12 little pie pieces that are 1/6 big. 12 divided into 6 equal groups looks like 12 wholes, and they're grouped into 6 equal groupings. But either way, the solution for both is 2 wholes. So, if 12 over 6 is the same as 12 divided by 6, is the same as carrying out the division problem and getting 2, this means that a fraction is made into a decimal by simply treating it as a division problem and solving it. 1 over 4, or 1/4, is the same as 1 divided by 4, which is the same as 1 whole could be the same as 1.00. That doesn't affect the value by putting a decimal and zeros after it. And then if I solve that division problem, 4 will not go into 1. 0 times 4 would be 0, and when I subtract, I get 1 as a remainder. But since I added zeros, I can bring down a 0 and keep going. 4 will go into 10 twice. 2 times 4 would be 8. After subtracting, there's still a remainder of 2. So I'm going to bring down another 0. 4 would go into 20 5 times. 5 times 4 is 20. And finally, there's no remainder. This means that 1 over 4, or 1 divided by 4, is the same thing as 0.25, or the decimal 25 hundredths.